Hey there, my pre-calc people. Today we're looking at 1 or 2.1 change in arithmetic, and geometric sequences. So when we think of sequence of events, you likely think of what happens first, second, and so on. But in math, sequence the same way, but it's like first element, second element, third element. The most famous sequence is the Fibonacci sequence, one of the first codes of all time. And it's found throughout nature. If you have me for geometry, remember Donald Duck and Adventures in Math Magic Land. And that one's 1, 1, 2, 3, 5, 8, 13, 21, 34. Next sequence is... I'm not going to tell you. First one to tell me what the next term is gets a pirate ticket. Alright. I just spilled water all over myself. That's cool. Alright. So let's talk more about sequence in geometry not geometry. In pre-calc terms. So, an infinite sequence is a function whose domain is a set of positive integers such that you have a1, a2, a3, a4, all the way up to a sub n. So the domain are positive integers only. If the domain, then it's a finite sequence. Okay? Some new terms. Nth term is general term. K is sometimes used instead of n. When I grew up, it was always k. Like you get a sub k instead of a sub n. A finite sequence only has a certain number of terms, and the term of the sequence is each number we're talking about. Whoo-wee! Let's just do some examples. Example number 1. A sequence has an explicit formula given below. Find the 12th term, a sub 12. Do you notice how that's an a sub n? So all I do is, in my formula, wherever I see an n, I plug in a 12. And that will give me my 12th term, which is 147. That's it. It's kind of like functions, but it's different. It's very similar. Example 2, write the first 4 terms of each sequence. So I need to find a1, a2, a3, and a4. So I plug in 1, I plug in 2, I plug in 3, I plug in 4. Alright, any questions while you did there? You can't ask, I'm on video. Wah, wah, wah. -1, 2, 5, 8. Went up by 3 each time. That's my slope. Alright, what about this beast? This one's a little bit different. So if I find a1, a2, a3, a4, right? So I plug in 1 to my equation. Plug in 2. I plug in 3. I plug in 4. That's it. That's all there is to this one. This doesn't, compared to last section, this seems pretty not bad. It's 4, 6, 4, 6. All right. Anything too scary? All right, let's get scary. Let's get scary. Find the first 3 terms of this. Find the, actually, try this one on your own. Pause the video and then hit play and see how you did. Okay? Try this on your own. Pause the video and then hit play. Okay? Boom! If you got 4, 9, and 14 by plugging 1, 2, and 3 in for n, give yourself a pat on the back. If you didn't, ask in class. And for B, if you got 54, you plugged in 11, congratulations. I'm proud of you. All right. Now let's talk about arithmetic. These ones have differences between terms. So we're starting with a term and then we're adding or subtracting from it each time. So before, the previous term actually didn't play a role, even though it kind of did, but I'll show you what that means. So this one, we're going to find a common difference between each term and treat that kind of like our slope. Okay? And then we're going to come up with our explicit, aka general form. That's going to look like this. I know it looks scary, but I assure you it's not. It's just saying where a of n is my term, I use a of k, my previous term, plus my change. Okay? So if my slope is 3, like our previous example, it went up by 3 every time. So if I took the previous example and added 3, it'd give me the next term. We can also see the formula like this. My a of n is equal to my change times n plus my initial, a sub o. And a sub o is my first term minus my change. It's going to make more sense when we see examples, okay? This is better not to memorize how to do it, but learn what's going on. So is this an arithmetic sequence? So is it going up by a constant each time? Well, it's going up by 4 each time, so yes, it is. The common difference is 4. Okay? Now for this one, to find my initial, or my a sub o for my formula, my before initial, I take my a sub 1 and subtract my d. My a sub 1 is 1. My d, my common difference, is 4. So a sub o equals -3. Okay? Now to find my sequence for a sub n, I take my d, which is 4, times n. I'm going to add on to it my a sub o, -3. Does this work? When I plug in 1 for n, do I get 1? Yep. When I plug in 2, do I get 5? Yep. When I plug in 3, do I get 9? Yep. So that's good. I don't know what just happened there, but it'll be all right. I was on the keyboard or something. Let's do 5 and 6 and call it a day. All right. Find the 46th term of this. All right. 2 ways to do it. First, let's find our d, our common difference. Well, it looks like we're going up by 3 each time. From that, can I find my a sub o? Well, I take my first term and subtract from it my d, right? So I do 2 minus 3 is -1. So a sub o is -1. Now I can write my formula for it. So my formula is going to be a sub n equals my d times n minus my initial, or plus my initial, but it's a -1. Now I can find a of 46 by plugging in 46. I plug that in, I get 137. Ta-da! All right, let's try a tricky one. All right, find the 9th term, whose first term is 8. So a sub 1 is 8. And common difference is -5. So d equals -5. So I need to find my a sub n. Right? Well, they give me my d. So that's going to be -5. N. But now I need to find my a sub o back here, right? Well, a sub o is equal to my a1 minus my d, which is negative 5. 8 minus negative 5 is 13. So I get negative 5n plus 13. And now to find my ninth term, what I need to do is plug in 9. So a sub 9 equals negative 5 times 9 plus 13, which equals negative 32. And we're done. That's it. If you have any questions, please ask in class.